Hello, welcome to next session. In this session, we will solve GATE 2019 Aerospace Engineering paper. Okay, question number 1 to question number 25 carry 1 mark each. Question number 1, the maximum value of the function fx is equal to x e raised to minus x, where x is real, is option A 1 by e, option B 2 by e square, option C e minus 1 by 2 by 2, option D infinity. So fx is x e minus x, and f dash x is x e minus x minus 1 plus e minus x. Okay, if we differentiate it, then it will be this. To find out maximum and minimum, we will put it equal to 0 and find out the value of x. So x is 1 and fx is your 1 by e. Okay, whether it is maxima or minima, we can check it by double differentiating, and double differentiation of it will be f double dash x is equal to minus e minus x minus 1 minus x e minus x. Okay, so e minus x is common, so that is minus 1 plus x. Okay, so for x is equal to 1, f double dash x is your negative. We put x equal to 1, then it will be minus 2, sorry, minus 1 minus x minus x, it will be negative. So if it is negative, then it will be maximum value. Okay, so answer is 1 by e. Option A is the right answer. Next, vector b is obtained by rotating vector a is equal to I plus j by 90 degree about k, where I, j and k are unit vectors along the x, y and z axis respectively. Vector b is given by option A I minus j, option B minus I plus j, option C I plus j, option D minus I minus j. Okay, so this is your I plus j vector, and when it is rotated about the z axis, it will reach at this position, so it will be just reverse of it. So here at x is equal to 1 and y is equal to 1, so when it is rotated by 90 degrees, so it is like this. So x will be minus 1 and y will be 1. Okay, so vector b will be minus I plus j. Vector b is just minus I plus j, or answer is your B. Next, question number 3. A scalar function is given by fxy is equal to x square plus y square. Take I and j as unit vectors along x and y axis respectively. At x, y, 3, 4, the direction along which f increases the fastest is option A 1 by pi bracket 4i minus 3j, B 1 by pi 3i minus 4j, C 1 by pi 3i plus 4j, D 1 by pi 4i plus 3j. So here pi is equal to or pi, or we can say this is fx is equal to x square plus y square. Okay. So gradient of f is your that is delta f is equal to curly f by curly x I plus curly f by curly e by j, or if we take this f as x square plus y square, so it will be the partial differentiation of f with respect to x, so it will be 2x, and partial differentiation of y, so f with respect to y, that is 2y. So delta f is equal to 2x I plus 2yj. Okay, so directional derivative or the direction of maximum increase at x equal to 3, y equal to 4 is this. Okay, so we will put the value of x and y and divided by magnitude, then that is the directional derivative or direction of maximum increase. Okay, or the fastest increase. Okay, that is if we put here 3 and 4, means 6i plus 8j divided by root 6 square plus 8 square, so 6 by 10i plus 8 by 10j, so that will be 1 by 5 3i plus 4j, so option C is the right answer. Next, the dimensions of kinematic viscosity of fluid where L is length and T is time are Option A LT minus 1, option B L square T minus 1, option C LT minus 2, option D L minus 2T. So the kinematic viscosity is mu by rho, and this is your tau by dy, and tau is your F by A, force by area, and du dy by rho. So the dimensions of F is mlt minus 2, and dimension of dy is L, dimension of A is L square, dimension of u is lt minus 1, dimension of rho is ml minus 3. So that is following this we have L square minus T minus 1. So L square T minus 1 means option B is the right answer. Okay. Next, phi function of x and y represent the velocity potential of two-dimensional flow field. Flow with velocity field v bar u x function of x and y I, and v function of x and y j, where I and j are the unit vectors along x and y axis respectively. Which of the following condition is necessarily true? Option A delta square phi equal 0, option B delta square into v equal 0, delta dot v into equal 0, option D u minus curly pi by curly v curly pi by curly v. If the pi exists, then it is a case of irrotational flow. Okay, so it is a possible flow. So for this this delta cross v should be equal to 0. Okay, so answer is option B. So if pi satisfies the Laplace equation, if pi exists, then it is irrotational flow. If pi satisfies Laplace equation, it is incompressible flow. Okay, so when the divergent velocity vector is equal to 0, it is also incompressible flow. Okay, so answer is your B. So when pi exists, it is irrotational two-dimensional flow. Okay, so answer is B. Next, for a quasi one-dimensional isentropic supersonic flow through a diverging duct, which of the following is true in the direction of flow? Option A, both the Mach number and static temperature increase. Option B, the Mach number increases and static temperature decreases. Option C, the Mach number decreases and static temperature increases. Option D, both Mach number and static temperature decrease. So this is your diverging duct. So when it is when flow is entering at here is supersonic, then because of the shape of this passage, the velocity will increase at the cost of enthalpy. Okay, because this is diverging passage, and flow at inlet is supersonic. So answer is B. The Mach number will increase and static temperature will decrease, because it is diverging duct. If it is converging duct, then the velocity will decrease. Okay, or the Mach number will decrease. But it is diverging duct with supersonic flow at inlet. So answer is your B. Next, question number 7. For a NACA 2415 airfoil of chord length C, which of the following is true? Option A, maximum camber is located at point 2 C from the leading edge. Option B, maximum thickness is located at point 15 C from the leading edge. Option C, maximum camber is 0.02 C. Option D, maximum thickness is 0.05 C. So this is your thickness. So last two digits represent the thickness of the maximum thickness of the airfoil. That is percentage of maximum thickness, or is 15% of chord, and second digit represents maximum camber position in percentage, which is 4%, and third digit represents maximum camber position. Sorry, that represents position, that is the maximum camber. Okay, so that is 0.001 C, or it is 2% of camber, or it is 0.02 in friction. Okay. So answer is option C.